Hey there, everybody. This is section 7.2 in chapter 7, initializing an array. Before we get into, a lot of the nitty-gritty here, I just want to take a moment to talk about what is happening when you initialize the elements in an array. So this is going to be, other programming languages, right? So let's just take a step back from pseudocode here for a second and talk about what gets put into an array when you declare an array in a compile and runtime environment. And the answer to that is it's hard to say. What happens typically, the rules for an array are as follows. The operating environment is going to take however much space it is that you are going to request. So, if we look at the previous example and we said we need 30, and we'll call it, int. We need 30 integer values worth of space. Now, whether or not you take all of that space, that's another thing. But what the system is going to do is set aside for you 30 integer values worth of space in contiguous storage. So that means it all has to be together so that 1, 2, 3, 4 all butt up against one another, and 4 dot 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 all the way to the 30th integer location all butt up next to each other. So these are 30 int storage locations. What has to happen is the size has to be set aside. Excuse me. What does not have to happen is this does not have to be empty. Excuse me. The space can be full of who knows what in there. So what might still be in here? There are other, previous values that could be in there. There could be parts of strings in here. There could be parts of doubles in here. There could be parts of images. There could be other programs that have little bits of code that are in there. And in a compile and runtime environment, that can lead to some pretty serious consequences because, in the running of the code, you're not going in there and double checking if the stuff that's stored in here is what you expect it to be. There is no way to reckon that. So what we would prefer to do is to actually initialize the variables and the values that are stored therein. So when we initialize the elements of an array, that's what we're looking to do, is we are looking to provide default values so that we can be assured that whatever is in that 30 int storage location is actually going to be 30 integers that we expect. Now, before we get into any of the nitty-gritty that we see down there, there's a couple of things we can do. We can actually, again, this would be a consideration for your compile and runtime environments. So when you go to Java or C++ or JavaScript, excuse me, etc., is you can actually give to it default values. Now, the default values for a number are 0, so that way you can test for a non-zero number, and string and I'm just going to say other, so if it's an object type of an array, etc., those are nulls. A null is not a 0. A 0 has a mathematical value, right? It's not the absence of a value. It's just a value that has a mathematically 0 value. A null, on the other hand, and that's kind of what this represents here, a null simply suggests that there is no data here, but this is a valid storage location. And this actually gives us something to test, and we'll talk about this in just a few moments here. So it's always a good idea to provide initial values, because this way I can be assured that whatever is put into my storage location here is actually going to map to what I expected it to do. So if we kind of zoom in here a little bit, on what we're doing here with loading content values into an array. These are constant values. Now remember, there's a difference between a variable and a constant. A constant does not change once its value is assigned, whereas a variable can. Now there are very few times in life where a developer can say they can maintain and manage control over an environment, and it's my suggestion to you, where you can manage things, do. So here we've got initialize month table. And something you and I both know about the months in a year is the calendar doesn't change, right? It is always January, February, March. It is always 12 months. We know there are always 7 days in a week. We know there are always 24 hours in a day. We know that there are only red, yellow, and green lights for a traffic sign, right? So in those cases, we have, as you can see here, constants. Now remember, there is something here to note. Here, you'll notice we have a single quotation mark for January, February, and then down here again at December. Do remember that for use inside of a system, we use the single quotation marks, whereas something going out to display to a user or out to a print or a digital display is going to have the double quotation marks. So here, we can use a little bit of shorthand because, no matter what kind of Gomer next developer in the chain it is that you have, probably they're going to know that if I start you here with January and February, I can end you up here at December with a really low incident of screwing that up, right? So being able to initialize this here in pseudocode, like we see right here, that removes any and all ambiguity from the next developer in the chain. And even with some lack of depth here, right? So we haven't done anything with these months. But nobody is going to be confused. Oh, you mean March, April, May, ... all the way through the remaining months there. So having initial content is always good inside of an array, especially when it comes to the stand-up compile and runtime environments, because you cannot be assured what is inside of the storage area that you have given to the array. It could be 30 integers, it could be 11 strings, it could be, other code from other programs that just happen to be running there. Here in pseudocode, you don't have to worry about initializing the array because the next developer in the chain, that's me, or any of your project teams, or, yourselves, you are going to have to manage, okay, this is what I'm doing with that space. And you won't have to follow the same rules, but it's good to know and just to file in the back of your memory for some other time that loading values into an array, or when you can, loading constant values into an array is in fact a really good idea. Continuing on, one of the things we keep saying is, arrays are great because they give us access to these big stores of data where we can actually do some kind of management with that data. So we can reduce the data set so we can actually find patterns and make decisions with the data that we've been collecting. Now, previously in these examples, potentially when you're thinking about, what do I do to work with loading, value into an array, I think it's really easy to think of the user as the primary interactant on one of these arrays. But really, probably the vast majority of all array interactions are, interprogrammatic, right? So from one function of a program to another, from one database to another, from one process to another, and there's no human interaction in there until the process is done. So typically, the way data would be loaded into an array is actually through a file. And here on the top of page 93, we can see that, where we are loading values into an array. So first thing is a suggestion here, set max number of elements to required value. That's suggesting that we know exactly how many elements there are in our array. Maybe. Sometimes that's going to be available to a system. Most of the times that's not. But that's actually something we can get around shortly here when we talk about arrays of variable size. But first things first. So we're going to set the index to 0 because the index, remember, is the element in the array that we are working with at this time. So we have to set that array index to 0 so that we can start looping through our array or iterating through our array at element 0 so that we're not wasting one of the data elements in storage that we can set aside. Just as with all do whiles, we have to read the first input. This is our prime read or our priming read. And then in the very same way that we have been using a do while with individual variables, we can use a do while in the same way that we would with a file. We can use them with array operations. So please don't think array operations are in any way, shape, or form different than file operations, because essentially they work the same way. The big difference is when you are working as a program or an individual with a file, you as a process or an individual have the only one true copy, right? That's the only one, and this is our golden copy, and this has to follow you around every place. That means that other processes that want to get in here just are not allowed. And that's not something we can have in a computing environment because your process might take way too long, and it might cause other processes to time out. So the looping structure here is exactly the same. The methodology we use to print from an array is the same, or to read values into an array is exactly the same. It's just that it's a new structure that we have to get used to. So here inside of our do while loop, you'll notice that we have two conditions it is that we can check. While input values exist, this suggests that we have a systemic way of knowing as an environment how many values there are in a file. And remember, in our file we have EOF, some marker to tell us that this is the end of a file and you can stop looping through here, post haste. The second one we have here, so we have that conjunction for and it's while index is less than max number of elements. This way, because again, remember, if I have set aside, let's say a 30 integer array, that space is only set aside for the total space needed for 30 integers to fill it. So this helps ensure that just in case I have 31 or 301 values in this file, that I'm going to get a notice that says, there was too many data elements to be loaded into this particular array. So that's what this particular AND statement does for us here. It gives us a way of ensuring that as a developer, I know if something has potentially gone wrong. Here, this line, array at index, so remember we're using this index to loop through our array, equals input value. So we're getting from a file a value, and we're sticking that into our array. Then we read the next input value, and then we loop back up here to the top of the do while loop, and we just keep doing it until we run out of data in the file. Now, this last piece here, this if input values exist, so we're suggesting, wait a second, are you still reading through that file? Crap. And index equals max number of elements, so you're still reading through the file, and I don't have any more storage space in my array? Yup. Then print out array size too small. That is a fantastic design inclusion for you when you're working with data. Because again, this is an automated process, right? There is no user input for having to iterate through the records on a file. It just does it automatically. You want some kind of output to make sure that you know as a developer that everything happened according to plan or something did not happen according to plan. If we get a readout that says 30 values were read in, great. If we get a readout that says 18 values were read in, that's okay too. I still have space, right? I've got 12 more storage locations before I fill up my 30 integer array. However, if it says that 32 values were read into there, I know that these last two simply went no place and that I'm going to have to go back and rerun this piece of the data read because these disappeared. If it tells me that 300 values were read in there, I know, crap, I got to go back and either do something logically to change that, or I have to do something with the storage to accommodate 300 data elements there. So we can read data from a file in exactly the same way we would have if we were just reading from a file. Instead, we're just copying all of those values into an array so that we can release the file so that it's available for other processes or it's available for other users in our development chain. Next, we have this idea of arrays of variable size. And again, this is on page 93 for following along with. This does not suggest that we have an array that can be dynamically sized. So if I have, set aside a space for 30 integer values, again, 30, and then I'm trying to read 31 into there, that automatically it's going to be resized for me. That is not the way that array operations work. There is no magic here. What essentially this one is suggesting is that, and this is the case, you are not always going to know exactly how many elements you're going to need for an array until a user or until another file tells you how many elements there's going to be in an array. So what this particular read values into variable array is suggesting is that we don't know how many values are going to be read into here. We're still going to have a max number of elements required. So this particular array has a total, a total maximum number. So we'll just reuse 30 here. But whether or not I read in 30 values or 18 values or 12 values or 2 values, that's going to depend on how much data there is in this particular file. So how do we account for the fact that sooner or later I am going to run out of data, potentially I'm going to run out of data in that file? That is what we use a sentinel for. So we're still using 999 here as a sentinel just so that it's consistent with what we've done previously. But each system has its own end of file marker, right? So we could actually say while input value is not end of file, because that's going to have a system peculiar whatever marker in there. I'm just using whatever as a stand-in for it's going to be different from system to system. So the EOF, the end of file marker in Java, is different than the end of file marker in JavaScript, despite the fact that they both have coffee-based names. So this is really just saying that we don't know how much data is going to be read into here. And frankly, it doesn't matter. As long as we don't go over 30 data elements, I can read 2 into here, I can read 1 into here. It doesn't matter. That extra storage is already set aside, and the fact that it's unused doesn't matter. That's nowhere near as terminal as having 300 data elements read into here, because 270 of those are going to be completely unaccounted for. So this is just assuring that we have enough space in this array to read values into. There's one additional little wrinkle here, so let me just get rid of some of this for us so it doesn't look as confusing. The additional little wrinkle in here is what happens right here. What we're suggesting is we've read in values, we've read in values, we've read in values, and you keep reading values in until you hit this marker 9999. So here, with this if statement, we want to make sure that if I've read in 1, 2, 3 values, but that's it, that the fourth element in my array is going to have the value of 9999. This way, when the array is being accessed again, it's going to know, okay, one, there's a value here, there's a value here, there's a value here. Oh, here's a value of 9999. I can start inputting new data here. And when I'm done, I can put, let's say 5 more elements are read into there. So I've got 3 elements already plus 5. So on our 9th element, that's the one after my last bit of data, this one is going to get 9999, so that the next time I have to add more data to the end of this array, I have a place where I can start that. So this is not really truly an array of variable size the way that I think people want it to be. It feels like entrapment. It feels like the loss of this magic that we have in computers, that it just works. This arrays of variable size is suggesting that, hey, you might have to have a very, very large array put aside for a very, very small set of data, and that's going to be okay, because we're still giving you tools, this sentinel value. So frankly, I would say EOF is just as good as 9999 for us. That sentinel value is going to give you something to make sure that you can keep reusing this array in a way that makes the most sense. Our final consideration here in 7.2 is paired arrays, and this is on page 94. The way to best consider a paired array is to think about the various data elements that make up any particular record in a file, right? So if I'm going to have students in a file, can't spell. If I'm going to have students in a file, you're all going to have FN for first name. You're all going to have LN for last name. You're all going to have ADD for address. You're all going to have S numbers for your S numbers. And these, when we read the data elements out, we're going to read each of those data elements out into a discrete array. So your first names are going to be read into a first name array. Your last names are going to be read into a last names array, addresses into an address array, and S numbers into an S number array. And the reason they're paired is because this array and all subsequent arrays, we want an operation that changes the index in one of the arrays to change the index in all of the arrays. So this way, if I'm referring to student number 1 for first name, student number 1 for last name, student number 1 for address, and student number 1 for S number, I'm referring to the same student. If I'm referring to, student number 5000 here for first name, 5,000 here for last name, 5,000 here for address, and 5,000 here for S number, I'm always referring to the same student. And the reason we do it this way is, again, because if I lock up this file for whatever data operation I'm doing, there are no other processes that have access to this file in a server environment. It's better and much faster to read, each one of these different data elements, the function or the first name, the last name, the address, and the S number. It's better to read these out into 4 discrete arrays, close the file, and then do whatever operations I need to do here on this array. So the new wrinkle we have here is we are reading product codes into one array. We are reading selling codes into another array. And you'll notice here that it's at the same index number. So what does that mean? It means that as I'm coming through and getting a product code, it's going to map to, later on anyway, it's going to map to the selling price that I need for that. So if this is product code, at 30, and this is selling price at index array 30, I'm going to have a product code and a selling price that are going to match up together. So a paired array doesn't mean that they are, permanently stuck together. It simply suggests that you're going to have one array or two arrays or multiple arrays. So here I have 4 of them stuck together. You can have 50 of them stuck together. And the operation I do on one array, I'm going to do it equally on all of the arrays so that I can do real, data sorting with them. So if you think about an Excel spreadsheet, because again, an Excel spreadsheet is a really great example of a multi-dimensional or numerous paired arrays. So if I have an Excel spreadsheet that has first names, last names, addresses, and S numbers, and I do a sort, right? So I click on S number and say descending order. It doesn't just change the column that's the S numbers, it changes all of the columns equally so that the S number for the least value, so like the student with S number 001 is going to get sorted all the way to the top. But then the address for student 001 gets sorted all the way to the top. The last name for student with S number 001 gets sorted all the way to the top. The first name for student with S number 001 gets sorted all the way to the top, and then your data remains consistent. That's the exact operation that's happening in the background. It's just that you don't or haven't previously had, logical access to that. Here, you're the developer and you are producing those changes. So the idea here of a paired array, there's no real change that's happening here. The only real change that's happening here is when I've got one array worth of values that I'm reading, I have to do the same to the next array worth of values so that they all essentially map correctly. So that this way, when I'm reading in from a file, first name, last name, address, and S number, Arthur Aardvark, that assuming is the first student, gets read into array at element 0. Because remember, arrays start at 0, and verbally we start at 1. So then our next student, Arthur Aardvarkus, goes into element 1 because that's the second one. And I read all of Arthur Aardvarkus's data into those arrays. An S number. That's really what the pairing suggests here. So we can really think of it as multi-array pairing or 2 arrays or whatever you need. And you've been doing this naturally in Excel all this while. It's just that now you are being tasked with getting the logic for that down instead of just being able to click time on sort in Excel and then Excel doing it for you. So congratulations, the curtain has been revealed, and this is what is happening in the background of an Excel spreadsheet.